Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at inequalities. The first one there, solve each equality and graph your solution on the number line. So we have 2x plus 1 is less than or equal to 7, where x is an element of n. Okay, so I'll come back to the type of number it is in a minute, but in this one, let's solve this like we would have any other algebra question. So we have 2x plus 1 being less than or equal to 7. Letters to one side, bring the numbers over to the other, or subtract 1 from both sides, whichever way you do that, and divide by the number in front of x. Okay, so I get this solution to it where x is less than or equal to 3. Okay, so you can see in this particular case there was no funny business in it. It's the same as if that was in equals. Okay, things like if this was a negative, that would change the sum and so on and so forth. Okay, so that's that part. Now we've plotted on a number line where x is an element of n. So this is where this part comes into play. Okay, so your number line is going to look like any other number line. So it has an arrow both sides. And then somewhere in the middle, we will have x is less than 3. So let's start at 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4. Okay, and in an ideal world, you'll have the same size or one box between each number. Okay, so x is less than or equal to 3. X is an element of n. Okay, so not surprisingly, I'm in my log tables again, and I'm going to the different types of numbers, which I know are here somewhere. Yeah, here they are on page 23. Okay, so it tells you what n is. N is the set of natural numbers, also called counting numbers, because if you start counting, you start at 1, 2, 3, 4. So if I was to describe them, I'd say it's the set of numbers that are positive whole numbers, not including 0. Okay, so 1 upwards. If I'm asked for x is an element of z, these are our integers, which are our whole numbers again. There's no fractions, but now they're positive, negative, and they include 0. Okay, so you can see that the natural numbers are part of z. Okay, rational numbers then, x is an element of q. This is trying to tell you here that they are fractions, p over q. Okay, so this is all the set of fractions. Okay, and of course n and z fit in here as well, because any whole number can be written as a fraction. Okay, you have irrational numbers that's not in your log tables. These would slot in here. And an irrational number is a number that cannot be written as a fraction. Okay, so rational is a fraction and irrational can't be written as a fraction. So root 2 is an example of an irrational number. If you put that into your calculator and you go S to D, you'll see that you'll get the choice of root 2 or a decimal, but you'll never get a fraction. Pi is another one that's an irrational number. I know we called it 22 over 7 when we were in our younger years, but strictly speaking, that does not properly round to 22 over 7. So pi is an irrational number, or you can write it as a decimal. And then real numbers is everything. Okay, everything feeds into real numbers. There's one more branch of maths on your course called complex numbers. These are not real numbers, and you'll know them by the letter I. So you'll be doing that at some stage. Typically schools do it in 6th year, but the odd school does it towards the second half of 5th year. Okay, but the important thing for this question is x is an element of n, so it's a whole positive counting number. Which means if I was to think about x being less than or equal to 3, well, it definitely includes 3. What are the numbers that are less than 3? Well, it's 3, it's 2, it's 1, it's 0, and it goes on here for infinity. Okay, so if I was to plot it, I put a dot at 3, dot at 2, dot at 1, dot at 0, 1, 2, and it doesn't matter how far you go down, as long as you do a big arrow in that direction to show that you mean every single negative number downwards. I am wrong. I did integers. My apologies, natural numbers. start at 1. Okay, so in fact, it's only 3, 2, 1. Okay, what I was plotting previously was x is an element of z. Okay, but it is not a z in this question, it's n, so it's just the whole positive numbers. So it's a dot at 3, a dot at 2, a dot at 1, and that's it. Okay, now I wanted to put one here that was x is an element of or. So you remember or was the real numbers, so that includes the whole numbers and the fractions, because I want to show you what does the number line look like when it's that type of a sum. Well, the first thing we have to do is work this out. So we have 3x minus 12 is greater than 5 2 is 10x minus 15 plus 17. 3x minus 12 is greater than 10x minus 15 plus 17. Okay, and just like before, I would do x's to one side and the numbers to the right, so that I end up with 3x minus 10x being greater than minus 15 is already on the right, 17 is already on the right, but it's the minus 12 that's going to move, and so he will change sign. He'll become plus 12. Just the same as plus 10 here became minus 10. Let's tidy up. 3 minus 10 is minus 7x, is greater than minus 15 plus 17 is 2. 2 and 12 is 14. Okay, I also liked this example because it gives me a chance to explain what do you do when the number in front of x is negative, as it is in this case. Okay, well, traditionally we would change the signs all the way across, and this is exactly what we're going to do here, except when it's an inequality, it also changes the direction of the inequality. Okay, so just to repeat that, to change the signs all the way across, and I do that because I want to solve for x, not minus x. So that minus changed to a plus, this plus changed to a minus, and the direction, excuse me, the direction of the inequality also has to change. And just like before, you divide by the number in front of x. So x is less than minus 2 is what I am getting here. Okay, so let's plot. Okay, so it's minus 2, so might start a little bit above it. Okay, and so on and so forth. You can see the two arrows show that the number line goes on forever. So x is less than minus 2, and it's a real number, so it includes all of the fractions and all of the whole numbers. Okay, so when it includes all the fractions, it includes all the numbers between minus 2 and minus 3, between minus 3 and minus 4. Okay, so in an ideal world, I would be, well, the first thing I'm going to look at though is minus 2. Does it include minus 2? No, and that's because I don't have the equals to sign here at the less than. It's not less than or equal to. So it doesn't include minus 2. So I put an empty circle at minus 2 like that. Okay. It does include all of the numbers though up to minus 2. So in other words, minus 2.1, minus 2.2, minus 2.3, minus 2.4, all the way. So all of the decimals or fractions in between. Okay, and all of the decimals in between these, and so on all the way down, which is why when it's a real number and it includes all the fractions, we tend to just draw it as a thick black line because it's all of those points superimposed on top of each other. Okay, so you end up with a thick line. Again, it goes on forever. It's less than minus 2, and it's quite clear that it doesn't include minus 2. That's why there was an empty circle there. So it includes all of the fractions up to minus 2, just not minus 2 itself. Okay. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.